We're just going to keep going on here and see. We should be able to get to the rest of the chapter. I do want to finish the IP section and then get into some DHCP and then NTP, which is Network Time Protocol. Both those sections are kind of short. We're not actually changing anything. We're installing it and just having it there. The DNS client information, section 1.3.1. Traditionally, the file etcresolve.config was a static configuration file that really needed to be changed, automatically changed by or it was automatically changed by DHCP client hooks. The computer can switch from one network to another often, and the resolve config framework is now being used to track these changes and so on and so forth. What's DNS? Yeah, what's the purpose of that? Absolutely. So if I go to google.com, I need to be able to get Google's IP address. I can't. Google within a frame means nothing. You wouldn't get anywhere. It has to have an IP address. So knowing of where that's going to be and actually setting up your own name services or whatever is very important. This is the client side, and they talked about it traditionally being in the etcresolve.config. Well, let's take a look at that real quick and see what it looks like. etcresolve.conf. And you can see that I only have one name server, and that's because that's what we set up within VMware Workstation in our little NAT world or environment. And it is 192.168.230.2. If we're using the school's addresses, we'll be typing those in. Even forgot what those were offhand. What is it? 172.16.16.130 and 131? 140, 141? That's what it is. Okay. Haven't actually typed those in for a while, so I usually have to look those up. But that's where that is. And you can change that, or if you want to do that, if you need to. A lot of the stuff is done automatically through DHCP. So if your DHCP server has the name servers in it, when it requests the address, it's going to dump that into your name server files. Let's see. We're going to skip the rest of that stuff. We're going to the next section, the static host names, 1.3.2. DNS is great if you have servers that are managed by the network that is going to be affecting the entire organization, and you actually have access to administer the DNS. So if I have a server called, FTP server, and I want people to connect to it, I'd put that in the domain name server of the school. If you're trying to do smaller home network type things, or if you're trying to just do something individually that might only affect this computer, you actually work through the hosts file. The host file has been around forever, since the advent of networks, of doing that resolving on the local computer. So instead of going out to a DNS server or DNS and saying, hey, what does google.com resolve to, I'm telling you where it's going to resolve to. This is the address that's going to be done. There are security risks in there. People have done that. They've gone to host tables and then changed it to go to a site that looks very similar to Google, but we can't edit it. Let's go ahead and actually do that. Oh, first, here, let's do ping test. If I do ping test, test doesn't resolve to anything. It's saying, what the heck is test? I don't know where that is. So its host is unknown. If I now edit my host file, and I'll use Emacs just for this example. I should use Vim. Again, I haven't done Vim for a while. At the host file, I do A for add, or insert. And now, just because I know this is a known address, is I will use, what can I use? I'll just do it back to itself. It's 127.0.0.1, tab over, and I'll call test. To exit out of the insert mode, I hit escape. I want to save this and exit. So I'm going to do colon WQ for writing the file and then quitting. And now I'm out. Now let's try pinging test. And it comes back fine. And it tells me that, in fact, it's pinging 127.0.0.1. If this is a web browser, I could have it go to any website that I wanted to. I could say that, printer or print server is equivalent, is going to be the specific IP address of the print server. So my machine would always resolve to that. Your host file has precedence over DNS. So if it's in both places, if you have a test server in DNS and a test in your host file, it always looks to your host file first. It only even goes to DNS if it can't find it in your host file. Typically, you don't have a whole lot in your host file, so 99.999% of the time, it looks at the host file, doesn't see what it wants, and then goes to a DNS system. Some places, though, have very extensive host files, and they sort of use host files instead of DNS. The important part is taking that host file and getting it around to all your clients, because it only affects my computer, not the client that connects to my computer. It's me on this computer is looking at that host file. So, static host names in the etc. The next part of the chapter of IP is dealing with bridging. If we had more than two Ethernet adapters, two NICs, we could bridge them. And if you understand bridging, it's essentially connecting them. So any devices that are on the network off the one NIC would now be able to directly communicate with the devices on your other NIC. You become like the router then, passing information back and forth, so you can set up routes and things. We're not going to do that. We don't have multiple NICs, so even if we wanted to, we couldn't. But it's not that important right now. Moving on, let's see, IP routing, TCP, ICMP, daemons, resources. Moving on to section 3, dynamic host configuration protocol. So this and then network time is the last two things we're going to talk about. DHCP is what gives us that address to begin with. Right now, we are relying on VMware's NATing and DHCP services to actually give me an address. To show that to you, if I go under Edit and Virtual Network Editor, this is the network we're using. We're using a NAT connection on our server. And right down here is our DHCP settings. It's telling me that I'm going to be using DHCP, and if I click on the settings, it's going to start assigning addresses from the 128 to 254 range. Now we're going to act on our server of actually looking at the DHCP services our server can provide. Section 3.1 tells us how to install it. We're going to be doing sudo apt-get install, and then the package that we're installing is ISC DHCP server. Do you want to install it? Yes, I do. It is on the top of page 47 of the server guide. Well, about a third of the way down. Otherwise, here's the command again at the bottom of my screen. It's under section 3.1 of the server guide, page 47. Now, just like I did under VMware Workstation, I went to DHCP settings. What address am I going to start at? What address am I going to end at? There's other information you can add, like what name server you're going to use. default gateways, all that kind of stuff. We can configure that all in here as well. We're not going to be doing a whole lot with it. I'll show you the configuration files. The documentation doesn't take you through in great detail, and in reality, we're not going to be using the server's DHCP in our class anyway. We'd have to have another client running to access DHCP to show it how it works. So I'm just going to show you the basics of it first. So we already installed the service, so DHCP is now running on our server. The files that we want to configure, I'm going to do sudo. I'm just using Emacs. If you want to use Vim, that's fine. DHCP, and then DHCPD.config. So it's a DHCP daemon, and then the configuration of it. If I'm looking at this, it tells me all the information. It gives me some basics. Option domain name example.org. If I'm at school, I'll be using the domain name go2ltc.edu. And then domain name servers. This is where we put in the school's domain name servers on. So when a device requests DHCP information, it's going to dump, the name servers into here. Scrolling on down, let's see here. It's asking for the subnet range and the subnet mask. And down here, and then here's the range of addresses that I'm going to be assigning. And so I tell it exactly, I want it to be 192.168.230.200 to 250, or whatever it's going to be. By the way, anything with an asterisk, a pound sign in front is remmed out, means it doesn't do anything. So once you make these changes, you would remove those lines, move those characters, and then it's able to actually function that way. There's a lot of information on this in other material. We're not really intending on getting the deep parts here, just showing that we can install it, and this is the configuration file of doing it. If you do make any changes into the configuration file, just like on the top of page 48, the very, very top of page 48, it says, after any configuration file changes, you have to restart the DHCP daemon by using sudo DHCP server restart. So not that difficult to do. Maybe later in the semester, if we get more clients connected or whatever, we're able to practice with that and do more with it. This chapter is just an introduction to it. Todd. You can stop where you are. If you have it installed, that's fine. I was just showing you the file. I definitely have to move this over here. Let's move this over. I was showing the file. It's etc DHCP daemon config. And I just showed you where you would change the different information. If you're actually going to do that, though, you're going to want a little bit more information. This chapter in our server guide doesn't get into that much detail. You would be looking at, Ubuntu DHCP configuration. No, you really don't. We didn't change anything at all. Okay, the last thing to cover is Network Time Protocol, or NTP. Time synchronization. NTP is a TCP/IP protocol for synchronizing time over a network. Basically, a client requests the current time from a server and uses to set its own clock. Behind this simple description, there's lots of complexity. There are tiers of NTP servers, with the Tier 1 NTP servers connected to atomic clocks. Tier 2 and 3 servers spread the load of actually handling the request, and then the client software is a lot more complex than you might think as well. It has to factor out communication delays and adjust the time in a way that does not upset all the other processes that runs on the server. But fortunately, that's all hidden from you. So Ubuntu uses NTP date and NTPD, which is NTP daemon. Okay, NTP date, it comes with NTP date as standard, and we'll run it once at boot time to set up your time according to Ubuntu's NTP server. And that's the command it's running. It's on 4.1. So on startup, it actually runs NTP date, and it's going to go out to the Ubuntu's NTP server, which is probably a tier 2 or tier 3. The NTPD, the daemon, calculates the drift of your system clock and continually adjusts it, so there are no large corrections that could lead to inconsistent logs, for instance. The cost is a little processing time and memory, but for a modern server, this is negligible. So it actually calculates, like, I checked yesterday and I checked today, we're off by a second. So you know what, throughout the day, I'm just going to adjust for that second. So, by noon, I'll bring you back a half of a second, or by 9 o'clock, I'll bring you back a quarter of a second. So it's always adjusting that. So the next time that you are actually checking with the server, we're going to see we should be really, really, really close. The installation, we'll just install that. Control-C. So sudo apt-get install NTP. Do you want to install this? Yes, I do. And it's pretty small and pretty quick. And it's done. So it took hardly any time at all to do that. It does give you the configuration file that you can look at and use for what time servers it's looking at. And that is etcntp.config. So if you can see down the bottom, it's using 4 Ubuntu servers. Oh no, NTP servers. I'm sorry, I was wrong. NTP servers. So ntp.org are the main ones. It's just Ubuntu has its own domain or something underneath there. So pool.ntp.org. If you really had your own local one, like maybe you have atomic clocks in your backyard or something that you want to connect to, you would edit this file and put your server's name on there, or whatever you think is a more accurate time, or easier, closer, more managed, whatever it's going to be. There's nothing wrong with these, so most people don't even change them. If you did make the changes, you would have to restart it, and the command is given on top of page 50. You're just doing NTP reload, essentially. You can view the status of what's going on. Let me get out of here. So I'm going to do the :Q. And to see what's going on, I can do pound sudo ntpq-p. Or I should do sudo. No, I want to get rid of that pound. That's wrong in the book. There we go. So this is what it's connecting to. It's IP addresses. And to be honest, I really don't know how to read this. 220, it's an offset of 220 something milliseconds maybe. But you can see I'm pretty consistent in here, across all the different time ones. The delay, it may measure the delay to that server, whatever. But it tells me that I am connecting to a server and it's updating and it's doing its own thing. I do not know the details on this and haven't really spent the time to research it either. When I compare the atomic clock to my watch, I'm off by minutes anyways, so by being partial of a second off, doesn't really bother me. But I realize that servers have to be very, very accurate. And that is it for Chapter 4. A lot of information, a lot of little commands or whatever. Again, this is where notes are going to come in. If I just want to, I want to install the network time protocol. It's a simple sudo apt-get install and then NTP. So So I'm not looking at all the complexities of it, just how do you do the basic things. So a couple sheets or whatever is all you really need. Taking a look at your user guide. The next chapter is DM multipath. Device mapper multipathing. You configure multiple paths between your server nodes and your storage arrays. We don't have any. So we're just going to skip this chapter altogether. And we're going to go from chapter 4 to chapter 6. So if you're looking at your learning plan, it's going to talk about chapter 6 that you should read for next time. It is a lengthy chapter. Let's see. Well, this is the next one, chapter 7. Let's see, 79 to 90. Oh, no, this one's not bad. This one's only 11 pages long or 12 pages long. I was thinking of combining this with the next one because it's a shorter chapter. And we may, in fact, start getting to chapter 7 because chapter 7 goes from page 90 to 139. So network authentication, LDAP stuff is like 50 pages. And it's really long. So definitely get into remote administration next week. Maybe starting to touch in the chapter 7. But if you could at least look through chapter 6, that'd be great. I do not have specific homework for you. I know a lot of people are asking on grading and things. I'll go back through and start giving you points for some of these activities like package management. You installed stuff today, so I know you can do package management. IP addressing, you know, I'll probably give you some points for that. It's going to become a lot clearer and a lot easier for me to grade when you actually install a service. Like I was talking about with a couple of you, I'm not sure, some of you might have been on break. You know, once you create an FTP server, I'll be able to see whether you have it or not, you know, by you being able to upload files or download files or whatever. Printing server is a real easy one. You'll be able to print something. So those are real concrete gradable things. This is sort of background stuff. You know, if I'm grading you on Windows, people usually don't grade people on Windows by being able to do a Windows update. It's more like, can you produce a Word document, or can you, you know, set up a printer in Windows or something like that. So a little bit more tangible things. So we're going to get grades. Don't worry about it. It's not going to be a terrible final. It's going to be just what we've done. Definitely use all your notes. And it'll be ahead of time, just some practical things. No written tests. I'm not testing you ever on Vim or Emacs directly. So I'm not going to have a separate, you know, 4-hour or 3-hour exam on Emacs, you know, and memorizing that 2-page reference guide. It's going to be, you need to edit the host file. Figure out how you want to do it. Non-GUI. Todd. I would definitely get in the habit of taking a snapshot. So you down your server and you can put like post chapter 4 or after networking or something. That way you always have a place to come up to, but you can go back prior and, you know, practice the stuff again. Because I'm sure, like, you guys are like, I'm listening to your homework level, and it doesn't sound like you have any homework in any classes. And so you're probably going to be bored this weekend, so maybe a little networking and IF configs and little emacking and vimming, you know, with your friends. So you want to be able to start from somewhere. Questions or comments? Bill, did you have a question? An additional question? Todd? Additional questions, comments?